All right, dude, we are live. What's up, guys? This is Dem Keys. That was a crazy voice crack at the beginning. But yeah, dude, what's up, guys? This is Dem Keys, and today we are gonna continue um, learning about Tokyo, just like we were learning last stream. I don't think I made too much progress since the last stream because I got busy doing some stuff. I was still doing research around, you know, Tokyo and Rust. I think maybe I did ask like one or two more questions in order to get some clarification because I didn't want to move past the topic. So we were doing the part where we are practicing arc and mutex and stuff like that, right? I wanted to get a better understanding of how all of that works before actually moving on to the next section of that chapter, which was talking about communication channels. Now, give me a second. Let me open up my stream manager and make sure I can see the chat. Okay, cool. So, what was I saying? Yeah. Um, wait, what are you guys able to see here? Let me just make sure. Actually, let me check here. Yes, yes. Okay. So, you are seeing the remaining conversation. Actually, are you? Hold on. I think I think it disconnected. Yeah, wait, hold on. The SSH session, I believe, disconnected, so I need to reconnect the thing. I'm hoping we don't have any disconnects today, but you know, that could still happen. We might, hopefully, even if there are disconnects today, then they won't be. Give me a second. Yeah, hopefully, if there are disconnects today, they will be shorter than they won't last longer than the disconnect protection. So hopefully we won't, completely disconnect and crash the entire stream. Um, but it would be preferable if, we didn't have any disconnects at all. Yeah. Okay. So, oh, holy shit, dude. I just noticed oh God, dude. My VTuber model is like going super slow. Holy shit. Well, not too much I can do about that. Um, it is what it is, I guess. Yeah, dude. At some point, dude, at some point I wanna try remaking this model in Nano, especially since I'm gonna be learning Nano. So I was like, okay, what if I try to remake this in Nano? I could, okay, so in Nano, I do have the option to decide whether I want it to be 3D or 2D. I could do 2D. I could also do 3D. I can actually mix 2D and 3D. By default, it's meant to be 2D. The workspace that you're working in, it's meant to be 2D, but you can actually draw 3D stuff onto it. There's a draw mesh API available. Um, but yeah, yeah. Um, I could try remaking the thing in Nano, and we can see how well that performs because Nano, I believe it does have an audio API to because Nano is meant to be a creative coding framework, so you can use it to build creative visuals and stuff like that. And dude, why is everything going so slow today? Holy shit, this is incredibly slow. Even OBS is running really slow. Not sure what's going on here. give me a second. I just want to check something in my browser. Right, there doesn't seem to be too much going on here either that would cause a slowdown, so I'm not sure exactly why. Is there anything running that could be slowing things down? Oh, could it be this website that I have open? Hold on. If that's the case, um, let me try opening the GitHub. Actually, no. If it would have been the website, then I think, it would have shown like CPU usage or GPU usage. Or so. Actually, I don't think it's going to show GPU usage in the process manager. Let me just check. Okay, it kind of is. Yeah, yeah. Okay, it is showing GPU usage. I'm seeing that here. Actually, that's kind of cool, dude. It's showing GPU usage. This this just clicked for me because I'm looking at the process manager and okay, wait. Let me close this down. I think the Tokyo website is running something that is using the GPU, and because of that, the GPU, um, whatever GPU related mechanism has been loaded, and it's also, putting some load on the GPU, which is probably why um, my other applications are kind of struggling. Let's see if the situation has. You're joking. You, holy shit, you've got to be kidding me. Having the Tokyo website open was um what was causing the lag. That's insane. What if I have um what if I just open up the GitHub page? Check, check, testing, testing. You know what? Okay, whatever. Yeah, I think things might be a little better now. Oh, actually, you know what else might be contributing to it? The rusty rain thing that I have going on in the background. I think that's contributing to it as well. Possibly. Though, if I'm being honest, I think in general, my VTuber application itself is kind of putting a load because it's a Unity application, so it does have a certain amount of background things that are running. And this is another reason why I kind of want to set things up in Rust and in Nano because I'm going to be in control of what all systems are being set up and run. So I'm hoping um, the application itself is going to be pretty lightweight. Speaking of Nano, I was talking about Nano when I kind of got distracted with, the lag. Nano does have an audio reactive thing. It has like an audio component that lets you do stuff with audio. I think it does also do the processing for you, but I'm not entirely sure. I'm gonna have to check. Even if it doesn't do the processing, I can probably use other crates to get that done. There are crates available for that purpose. We can actually look that up right now. Hold on. I don't know if Nano. Actually, let me check this. Let me check this out on a different machine. Okay, Nano Home. Just give me a second. Let me finish. Let me find the thing that I'm looking for, and then I can open it up here. Okay, so we got Nano, and in Nano we've got a bunch of different modules. Audio doesn't seem to be mentioned here, even though I've seen audio explicitly mentioned. Wait, I've also seen GLAM. What is GLAM supposed to be? Is a simple and fast linear algebra. Oh, okay. I should keep that in mind. Okay, I should keep that in mind. There's a draw API for 2D and 3D graphics. No, where's the audio thing? Is that like a different crate? Maybe it's a separate crate that you can, add to. Okay, so there's I guess these are different crates. So there's nano audio, nano core, nano EGUI, and a bunch of other nano stuff. So I guess you add whatever you need to add. Okay, so let's open up nano audio and then I'll open up nano here as well. Okay, the audio API for Nano, the creative coding framework. Please see the Nano guide for more information on how to get started with Nano. Some of the features of this API include access to the available audio devices on the system, spawn any number of input and output audio streams, simple builder API. Actually, I'm curious about this spawning audio streams thing. Oh, it's audio streams, not audio devices. Okay, I need to keep that in mind. Simple builder API for establishing streams with reasonable defaults, requesting consistent buffer sizes and for input and output audio streams, no matter the backend, and an easy to use non-blocking API. Nano Audio uses and contributes to CPAL, a pure Rust cross-platform audio library for handling the low-level cross-platform stuff under the hood. Okay, so this is gonna help us get audio into Nano. I guess we're gonna have to apply our own processing to it, which again, there's crates available for that. I just need to integrate that within Nano. We're gonna need to apply our own processing to it in order to make it usable for VFX, for like audio reactive stuff. Actually, okay, hold on. I hope this is not gonna. Wait, hold on. So let's load up the. This is the Nano guide. Do I have Nano open here? I don't think I have Nano open. Though I do need the guide as well. So let me open up the guide. And we can probably unload this Tokyo page. Actually, no, I think I'm going to be going to the Tokyo page later on. Let's see if they set up something for audio. But before that, wait, I need to do the search. Right. Okay. So while that's loading up, I can show you guys the Nano manual page, Nano guide thing. So these are a bunch of guides that have been, I believe, written by different members of the community. Let me see if there is an audio example here. So there's anatomy of a Nano app. There's drawing a sketch versus app, window coordinates, 2D shapes, animating a circle, drawing images, OSC introduction, and then sending OSC messages. So I'm not seeing something for audio. Um, Wait a second. There might be a different examples section. So Nano itself does have an examples section We're going to check that out, but then we'll also check out the. Oh, okay. Yeah. In the examples section, there's an audio thing. Actually, I should keep this in mind. I should explore these examples as well, and not just stick with the not just stick with. Hold on. Let me form the sentence properly. I should also take a look at these examples and not just stick with the tutorials that are on the nano, what do you call it, manual website. You know, something I could do, um, because I have Gemini CLI now, I could clone this repo, and then for each of these projects, I could tell Gemini to study the project, and understand that it's an example, and then prepare a manual or a tutorial sort of thing for me. So then Gemini could teach me what each of these examples are doing. That's actually a great idea, dude. Dude, holy shit! I could do this for a couple of other frameworks as well. I could do this for Ratatouille as well. I could definitely do this for Ratatouille. Holy shit, dude. Okay, so uh here they have simple audio, they have record wave, which is great. I'm guessing that's for getting live stuff and also, recording. Because, okay, getting live stuff, something that I've noticed is that when we talk about getting live stuff, essentially it's just recording, but you're recording samples. You're recording a certain number of samples every second, and you're doing that recording for a set number of seconds, and then that becomes your chunk. And once you've recorded that chunk, then you write it and you start recording a new chunk. That's essentially what the live thing is. Or, well, not necessarily record it, but like store it somewhere, or do something with it, send it off for processing or whatever. But essentially, the live thing, quote unquote, live thing, at least when you're trying to implement it programming wise, this is what it ends up being: recording a bunch of samples for a couple of seconds, and then sending off those samples, and then recording a couple more samples and sending off those samples. And because it's happening continuously, so it seems like a seamless kind of thing. Okay, so let's take a look at record wave. Um, we have nano audio buffer. Okay, file. Okay, so this is going to record and then write it to a file. Records a wave file using the default input device and default input format. The input data is recorded to so and so. Okay. All right. Um, okay, what does a capture look like? So, a function that captures the audio from the buffer and writes it into the wave writer. When the program ends, the writer is dropped and data gets written to the disk. So this is storing it in the writer. It's not immediately writing this to the file. So capture for frame in buffer.frames, for sample in frame, audio, writer, write sample. Okay. Okay, okay, okay. Dude, okay, this is gonna be interesting. This is gonna be interesting because I feel like, okay, there have been a couple of other situations where I needed audio to be recorded real quick, like record the audio sample, let's say my own voice, just a small clip, and then I wanted to do something with it, maybe save it, maybe process it, apply filters to it, or something like that. And doing that through Python was a little bit complicated. The simplest methods that I could find were with two libraries that I had found. I don't remember their names exactly. Um, I think one was called Pi Audio and the other was called Sound Device. I can't remember exactly, but one of them, it did have a thing where you could record audio and you could also play audio, and in that I kind of saw this in through that is how I actually learned that okay, this is how recording is done. It's recording samples. Um, the sample rate defines or dictates how many samples there are per second of audio. And so, you know, when you're capturing a couple of seconds of audio, or if you're trying to capture a long session, and then if you're trying to capture a long session, then you don't want to capture the entire thing as, how do I say this? You don't want to be capturing like every second, I guess. There's a thing where they kind of decide, okay, we can have a chunk of audio samples, um, and every few seconds we we recreate the chunk. So once the chunk has been recorded, then we save that somewhere and then start recording the new chunk. I don't know if I explained that very well, but yeah, yeah. Um, dude, you know what else I wanted to do? I wanted to try and set up like a soundboard kind of application. I remember back in the day I wanted to do this in Unity, but I never actually ended up doing it. Um, Also, dude, I really don't think I'm going to be using my as as sad as it sounds to say, I don't think I'm going to be using my um I don't even remember what I called it. It was like a remote control application that would be sending messages. It was supposed to be a Stream Deck. It was called Virtual Stream Deck. I remember because well that's what it's called. The name I'd gotten it from the physical Stream Deck hardware, where you have like a console with a bunch of buttons, and then you can program each of the buttons to do something. That's where I'd gotten the idea from, and I created that using Streamlit um, and Python. Though, you know what I could do? I feel like now if I try to recreate that application, because I now have much more experience with building this kind of thing, and I have a better idea of what exactly I'm looking to do and what is possible to do, I could try recreating this in Rust. I could try. I feel like that would be a I feel like that would be a fun little project. Though I don't necessarily require that kind of thing right now. But yeah, okay. So we are looking at the record thing. Let's take a look at simple audio. Is this just for playing audio? Initialize the audio API so we can spawn an audio stream. Initialize the state that we want to live. Initialize the state that we want to live on the audio thread. Okay. All right. Stream.play. How's the audio being loaded? So there's new output stream model dot render audio. Where is it pulling audio from? Where has audio been defined here? Model has been defined. Yeah, where is it getting this specific audio from? I'm trying to find that in the code. I see an audio host. I don't see. Oh, this this audio. It's passing in this audio. So the render function probably takes something else. It's not taking, for some reason I thought it's taking audio samples. This it's probably taking something else. Um, I, I guess we'll find out later on once we start exploring Nano. But yeah, I should definitely look into trying to build a very simple puppeteering application. At the very least, I would want it to be audio reactive. But if I'm being honest, I kind of want a little more animation in it, a little more than what I currently have. But at the same time, I also want this kind of a design. I kind of like this kind of a design. Um, I would want to make something similar to this again. But yeah, I wanna get creative with it because there's lots of stuff that I can do um, through Nano. I'm also thankful that took I in the past I took the time to explore a bunch of different math algorithms, two specific ones that stand out in my mind, which actually got me to do research on a couple of other similar algorithms as well. This was before Gemini, so now if this was before before LLMs were even like a widely spread concept. Um, so most of my research was done through Google. Now I could ask Gemini. I could tell Gemini that, hey, I've learned about these two algorithms. I'm wondering if there's similar algorithms that you can tell me about that I could implement. So the two algorithms that I did learn about were the Lissajous curve and the Rose curve. And something I found really interesting with both of these algorithms, they're parametric equations, which means that you can change the parameters and you can watch their results change. And that's what makes both of these curves really special because you can come up with really interesting designs using both of these algorithms. Like whether it's like an active ongoing design or if it's a final design that you're trying to sketch out. Like you can, for example, animate a really long trail. You can animate an object that has a really long trail. So it basically becomes like using a pencil on a paper, right? The animation that you're doing, you can animate its 2D and well, you can animate its 2D position. I was about to say 2D and 3D, but the 3D part, like adding the extra dimension becomes a little more complicated. It's possible, but like you'll have to find a way to do it. By default, the thing is meant for 2D. So you can animate its 2D position, meaning its X and Y position. And because there's a trail attached to it, so as you're moving the object, this object is going to move along an imaginary rose curve that has been calculated using the algorithm. And as it's moving along this imaginary curve, because it has a trail, so you are actually drawing that exact curve. So in the end, like if you let that algorithm run for a couple of seconds, you're going to see an actual rose curve design being drawn. That's something that I found like that was mind blowing to me. Like that was something really interesting for me. And I do want to find more such algorithms. I actually also want to see if because I'm sure somebody must have implemented a library that does something like that. Currently, a library that I'm definitely planning on looking deeper into. There were two. What was the other one? Was it called Lyon? Right. So one is called Lyon Tessellation, and the other is called Noise RS. Noise RS, it's a Rust library for procedural noise generation, but it gives you a bunch of extra uh, functionality as well. There's a bunch of other stuff that you can generate as well. You're not limited to just noise functions, but you can create a lot of like texture, texture related functions. You can create designs that are mathematically described across a surface, which basically means that you can use the result of those mathematical calculations as a whole texture. If you write that to an image, you get a texture. I can show you guys both of those libraries. The interesting thing is, Lyon is it's a path based thing where you're describing a path that the design is going to follow, um, and noise is where you're using a mathematical algorithm or a set of algorithms to generate the to procedurally generate a texture kind of design. They both accomplish two different things, and I feel like both of these things can be incredibly useful for me in my creative coding journey, because I do want to get into like doing live VFX stuff. That's always been an interest of mine. I'm also developing custom hardware to be able to do that. uh More on that later. But yeah, it's hold on. I'm gonna open up both of these and show it to you. You know what? We were supposed to be learning about Tokyo. I don't think we're gonna be learning about Tokyo. um, Hold on. I am gonna switch to, oh, I accidentally hit my Windows key. Give it a couple of seconds. Okay, I think we're good. Right. So let me load up the those two repos that I was talking about, and then I can show you guys what I'm planning on exploring. This is something that gets me really excited about working on graphics and game dev related stuff in Rust. I've mentioned this before as well, but like when you're doing it in Rust, unless you're using a full-fledged framework like Bevy, which by the way does incorporate a bunch of other crates functionalities and also gives you a bunch of its own functionalities, which the devs of Bevy have been building. Unless you're using a full-fledged framework, you're going to end up having to get a bunch of crates together to or piece them together in order to build functionality. And while that may seem a little bit tedious, it's also incredibly powerful because it gives you the option to customize things in your own way and also keep things lightweight. So if you have a specific thing in mind, give me a second. I need to load this. So we have noise RS and then Lyon. Give it a second, let this thing load. Hopefully it doesn't freeze. Okay, okay. Fortunately, it didn't freeze. Though I just realized that maybe I shouldn't be loading up this GitHub page because it has a bunch of like GIFs and images and stuff that load up, and that's definitely going to slow things down. Um, just a second. Lyon Rust. Let's open that up as well. And now we can take a look at it. Okay. So now I'm going to switch back. Something else that I noticed, speaking of Rust, whenever I'm setting up a stream or setting up the stream info, in the info you're able to set tags for your stream. I have a couple of tags. Um, I try to mention the tag of the programming language that I'm using. Usually it's Python, right? But on days when I'm doing Rust, if I'm feeling kind of lazy to change the tag, I'll just not change it. So I'll have the Python tag while I'm actively doing Rust stuff on stream. It's not that big of a deal. Um, but when I do want to change the tag to Rust, now Python is well known, right? You type Python, you're going to see a bunch of Python coding streams. If you go on Twitch and look for the Rust tag, it shows you the Rust game, and there's like hundreds of streams of people just playing Rust. It has nothing to do with the Rust language. So that's unfortunate. You have the language called Rust and the game called Rust. So when you search up Rust, it's definitely going to show you the game, because the game is what's being searched for the most, at least on Twitch, right? So the Rust tag has been taken over by that by the game instead of the language. Another very common tag is Rust lang, which makes things a little less ambiguous. So it gives people a better idea that, oh yeah, we're talking about the Rust language. I tried looking up Rust lang, and that tag is dead on Twitch. There's nobody using that tag. At least at the time when I checked, there was nobody using that tag. So I have no idea. I'm gonna have to search. I'm gonna have to go and look who is doing Rust coding and what tags they are using, specifically Rust related tags, because there are other tags like VTuber and coding and programming and stuff like that that I add in there anyways, but I'm looking for like Rust specific tags. Okay, so this is Noise RS, a procedural noise generation library for Rust. Okay, here it shows us a couple of examples of stuff that you could build using this. Wait, where's the examples gone? Oh, it's here. It's here. Okay. I'm glad that they gave it its own separate section. I'd actually forgotten that they gave it its own separate section. I don't know if you guys can see this the scroll bar on the right side of the page, or if it's cut off because of the way that I've cropped the thing, but this is a massive page. This is a massive page. There's a lot over here. So it's probably a good thing that they gave it its own section instead of, you know, instead of putting it on the main page. And of course, there's, example code as well. So this is the great thing about this, right? This library, it doesn't really care about the backend. It doesn't care about what you're going to be doing with this information. It doesn't care about whether you are trying to write this information to an image, or if you're trying to use this information for some real-time application, or if you're feeding it into some kind of like audio synthesis program that's going to do something with that information. It doesn't care about any of that. It is only concerned with generating the data across a certain surface. I don't know what the I don't know if you can define the surface that it is being generated on. I'm assuming it's 2D and 3D. It gives you the option for 2D and 3D information, and you'll get your results according to that. Actually, there's 1D as well. Sorry, there's 1D, 2D, and 3D. It gives you the option for all three of these. And this is the important thing. It doesn't really care about what exactly you are planning on doing with the information. It's just giving you that information. You can then apply that information to anything. I feel like once you understand that concept, there's a lot that you can do. Like there's a lot of creative ideas that you'll get once you understand that these are just algorithms that are giving you information. They're creating the data and giving it to you, and then you can do whatever you want with the data. So you can, like I said, write it to a file, or you could apply it to some real-time rendering application, or feed it into, some audio thing or whatever. So this is Noise RS. I'm going to be exploring this at some point later on. There's, as you can see, lots of different options. This is what I was talking about. It mentions, so the library is called Noise, right? But there's a bunch of extra options in there as well. You're not limited to just noise. There's a bunch of extra stuff that you can build as well. It's basically the library is called Noise RS, but it's a procedural generation library. It allows you to do a bunch of procedural generation. I should keep this in mind because in the past there have been situations where I wanted to generate textures for various things, and I just, at the time, to be fair, I didn't have as much knowledge about these kinds of things. Like, for some reason, it just didn't occur to me that I could try and look for a library that can do this kind of thing. Otherwise, I would have looked for it. At the time, what did occur to me was to try and use programs that do this. So stuff like Krita or Photoshop. Photoshop is just out of the question for me because I don't use it, whether paid or pirated. I just don't use it. I've mainly used Krita for years, and now I haven't touched Krita in a long time either. But like, yeah, when I did need to generate something, then I would use Krita for it. Now I should keep in mind that I have Rust for this. I have a bunch of these libraries for various purposes available. Okay, let's scroll further and show you guys. There's a bunch of different types of things that you can build. They show you examples of various things. And it's kind of interesting what you are able to come up with when you start combining these things together. Like, you don't always have to combine them, but like, once you start combining all of these things together, you can come up with something really interesting. I have some ideas, dude. I have some ideas that I want to. Dude, this is actually perfect. This is the perfect thing to use when experimenting with a creative coding framework or anything that does rendering in any way. This is a perfect thing to use to explore those kinds of frameworks, because like, I could define, or I could describe what is supposed to be rendered in Nano, using the data that's going to be generated, the procedural generation data that's going to be made. I could feed this into those functions for drawing stuff on the screen. um just I'm continuing scrolling to show you guys the, oh, what is this? This is interesting. Select. What does select do? This is something similar to what I was planning on doing in another situation. There's also, okay, so I mentioned that I wanted to build a live VFX application. And so I've been having conversations with Gemini about ideas. I've been trying to get ideas from Gemini for stuff that I could do. And I need to save those ideas. So far I've only saved the checkpoints for those conversations, just so the information is not lost when I close the Gemini instance. But at some point, I should export that entire conversation as an MD file so I can later on take a look at it. I can also, like, filter out the information that I don't want. Select. Okay, you know what? I'm gonna explore this later on. Hold on. Where is this coming from? I'm curious about this. So there's plane map. Oh, it's plane. I thought I saw the word planar. Um, where? Hold on. Yeah, where is plane map builder though? Oh, maybe it's part of this. Maybe it's part of this. Okay. Right. So what was the next thing I was going to show? Lyon. So this is a 2D graphics rendering. This is 2D graphics rendering on the GPU in Rust using path tessellation. Dude, you know what's crazy? On Rust or through Rust, in the Rust ecosystem, I've learned that a lot of times when it mentions GPU, because like previously, if I would be seeing something saying, "Oh, this does so and so thing on the GPU," my first concern would be, okay, what if I'm using a machine that doesn't have a discrete GPU? Fortunately, a lot of times when, at least in the Rust ecosystem, a lot of times when libraries say that they're doing stuff on the GPU, I can't say for all cases, but like in a lot of the cases, I've noticed that they build their GPU support on top of WGPU, as in web GPU, and because of that, it kind of abstracts away the requirement for, I don't know if that makes sense, but like it abstracts away the concern for what kind of hardware it's going to be running on. As in, the library is not built specifically for a discrete NVIDIA or AMD GPU. It could also run on I forgot what it's called, but it's like an internal GPU that Intel CPUs have. Um, I forgot what the thing was called. Yeah, yeah. I can't remember exactly what it was called, but it's like Intel HD something, right? It's a specific kind of GPU that Intel CPUs have. I'm pretty sure AMD CPUs also have them. But yeah, these are the GPUs that get used when you don't really have um, a discrete GPU, and these GPUs aren't necessarily always, you know, as powerful as discrete GPUs, but a they still do a decent job. They can still do rendering work. That's why even on machines where you don't really have a discrete GPU, you're still able to play games because it's able to offload a lot of those calculations to the GPU. It's able to do a lot of the rendering through that inbuilt GPU. Now, going back to Rust, something that I learned is that a lot of times when it mentions GPU support, or a lot of times when it mentions that it's doing stuff on the GPU, it's built on top of web GPU, meaning web GPU is going to be handling the it's going to be handling the rendering work. That becomes like an extra layer in between your graphics API and the games or, you know, applications rendering code. So you don't necessarily need to have a discrete GPU because web GPU also supports the Intel internal GPU, and web GPU also supports something on the browser. I forgot what the thing is called in the browser, but because of this, you're able to run those exact same applications on a discrete GPU, on an Intel GPU, or even in the browser. Okay, so Lyon, a path tessellation library written in Rust for GPU-based 2D graphics rendering. Motivation. For now, the goal is to provide efficient SVG-compliant path tessellation tools to help with rendering vector graphics on the GPU. For now, think of this library as a way to turn complex paths into triangles for use in your own rendering engine. The intent is for this library to be useful in more projects like Servo and games. Now, hold on a second here. Oh, you know what? Okay, this is giving the information that I was looking for. I was about to open up a new instance of Gemini to ask it the question about, you know, um, about path-based and tessellator-based rendering. Tessellators, such as the ones provided by Lyon, take complex shapes as inputs and generate geometry made of triangles that can be consumed by graphics APIs such as OpenGL, Vulkan, or D3D. So that's the thing of that's about tessellators. I actually forgot that that's what tessellators do because like the first time I'd come across the concept of tessellation was when I was doing shader coding in Unity, and there was a tessellation stage that you can program. Um, that's when I started doing research about tessellation because I found out that okay, there's this concept where you can there's a stage where you can actually take a triangle and like subdivide it into smaller triangles and then do a bunch of interesting things with it. And all of that happens on the GPU. But I never really dove too deep into it. Um, right, hold on. I wanna ask this question. Um, I need to create a new Gemini instance, and that might take a couple of seconds. In the meantime, do they have an example section that we can take a look at? There is an example section. Okay. Just give me a second here while I... Okay. Web GPU. And in here we have... Okay, so this is an example program showing what integration Lyon tessellators in a GPU-based renderer could look like. What integration? Integrating Lyon's tessellators in a so-and-so could look like. That's pretty cool. This program renders the Rust logo, fill and stroke. The geometry is tessellated once at initialization and stays on the GPU. Some parameters, such as color and stoke, uh, color, oh, do they mean stroke width or is stoke meant to be something? I don't know. Let's find stoke width are stored in a uniform buffer that are updated every frame. Opaque geometry is drawn in front to back order with the depth buffer enabled. Oh, okay. Give me a second. This thing is done. Let me start up Gemini. I'll ask the question here. I actually could have started up the Gemini instance on the other machine and I could have asked a question there. That just occurred to me. But the other thing is, whenever I start up Gemini, I have no idea if it's going to suddenly start asking me to re-authenticate. And on this machine, I haven't set up the other authentication method. So I need to be a little bit careful when I'm doing stuff. Give this a couple of seconds while it starts up. In the meantime, I guess I'll hydrate. Hey, so I'm gonna be exploring um, the nano library soon, and I also came across Noise RS and Lyon, which, from what I understand, can help me generate various things that can be fed into Nano's renderer to draw on the screen. The thing is, I'm going to add in noise RS anyways, just so it gives a nice detailed explanation of that as well. I don't fully understand what exactly noise RS and lyon do. Um, what are they? What functionality are they providing? What drawing methods are they using? I'm just going to throw in a bunch of questions so it answers the questions for both of those libraries and we get like a bunch of information to look at. What drawing methods are they using? How are how are we meant to be using the data that they provide? How are they meant to be used with Nano? Um, I'm pretty sure these both these libraries work on different concepts, so I would also like to explore uh, all those concepts in detail if possible. Okay, so we're going to get an answer. Um, okay, give me a second here. We're going to get this entire thing. Okay, give me a couple more seconds because it needs to regenerate some stuff. Let me just make sure that the information that I'm looking for is right there. How to use it with Nano, functionality, and data usage. You use a path builder. Okay, path, the primary input to lyon. You build a path by issuing commands like move to this point, draw so-and-so. Okay, vector graphics, tessellation. Okay, could you go into much more detail with lyon? I feel like I haven't understood that whole path thing very well. Okay, okay. There's a good amount of information here. There's an holy shit. This is a crazy amount of information. Okay, so now we are gonna export this chat or share it to uh, Gemini explains noise and lyon dot md. Okay, so that's been saved. Now let me open up a new tab so I can grab that. Um, CD, scratch stuff, Gemini explains noise. Okay, so we're gonna, I just realized something. I think one of the reasons why it maybe takes a little extra long for Gemini CLI to start up is because the directory in which I'm opening Gemini CLI, it has subdirectories, and a couple of those subdirectories are actual projects, and actually a couple of those subdirectories are full-on repos, so they have their own subdirectories and a bunch of extra files and stuff. I think all of that stuff is being traversed by Gemini CLI, and so I think that's contributing to the lag. Okay, give me a second. GG goes to the top, doesn't it? I think so. Yeah, GG goes to the top. Okay, then there was another thing where it was talking about some loop detection or something like that. Yeah, there was a thing where it was talking about loop detection, and it was asking if I want to continue. I did decide to continue, but I'm not seeing the loop detection warning here. How come I'm not seeing it here? It just continues to the next thing that the next question that I asked, which was, okay, could you go into much more detail with Lyon? I haven't understood the whole path thing properly. And then, yeah, I don't know. Let me go back up here and see what that looked like, because it had a thing where it was like, okay, oh, okay. It reformatted the entire answer. That's why. So it did the loop detection thing, and when I said that disable loop detection, then it just regenerated the entire answer. Okay, so yank all the way to the bottom, and now let's create a new file here. So neovim Gemini explains noise and lyon.md. Okay, done, save, and quit. So now we can open this up in Frogmouth, which is our markdown viewer, and we can explore this. So I can close this file now. I can I think I should also delete this. I don't think I need to keep this file around, though. Okay, let me keep it around for now. Okay, so let's explore this. I said, hey, so I'm going to be exploring the Nano library soon, and I also came across Noise RS and Lyon, which, from what I understand, can help me generate various things that can be fed into Nano's renderer to draw on the screen. The thing is, I don't fully understand what exactly Noise RS and Lyon do. Um, I, I I actually do understand to a certain extent, but there's still quite a lot that I have to explain, that I have to explore. So I was just like, okay, I don't understand anything about them. Just teach me from scratch. Okay, continuing. What functionality are they providing? What drawing methods are they using? How are we meant to be using the data that they provide? How are they meant to be used with Nano? I'm pretty sure both these libraries work on different concepts, so I would also like to explore all those concepts in detail if possible. Oh, you know what? I think this is where, okay, this is probably why it didn't get recorded. If, because there was that loop detection thing, I need to look into what that loop detection issue is because, like, once in a while that'll pop up where it detects some kind of loop in what it is doing, in what Gemini is doing. And then it's like, okay, potential loop detected. Do you want to abort this or do you want to disable loop detection or what? So I disabled the loop detection and then it regenerated the response for the prompt. And this time, this is the response. Of course, let's break down Noise RS and Lyon and see how they fit into the Nano ecosystem. They serve very different but complementary purposes in generative art and creative coding. Noise RS, the data generator. Noise RS is a library for generating procedural noise. It doesn't draw anything. Its sole purpose is to generate coherent, natural looking pseudo random data. Core concepts. What is procedural noise? Unlike pure randomness, um, where every value is independent, noise functions produce values that have a relationship to their neighbors. If you ask for a noise value at so and so, it'll okay. So this is explaining the concept of noise, and fortunately, I understand this because I actually studied about Perlin noise years ago, and I even made a tutorial on Perlin noise. So I kind of understand that some of these are what you call pseudo-random uh, data, or the data generated by functions like Perlin noise are they're considered pseudo-random data. They're not really random data. They're based on an algorithm, and they always give you a predictable result. So for any given set of values, you'll only ever get the exact same quote unquote random value. Okay, where was I? Yeah, okay. So here it's explaining that the value at so and so position will be similar to the value at a nearby position. So like if you are feeding in positions that are nearby each other, then the random values are also going to be nearby each other. This is actually what allows you to generate a nice smooth kind of motion as opposed to the choppy kind of motion that you would get with with truly random data. Okay, this coherence is what allows it to generate smooth, organic-looking patterns, textures, and movements reminiscent of natural phenomena like clouds, terrain, or water. Noise functions. This library provides various algorithms for this, like Perlin, Simplex, Worley, and Open Simplex noise. Each has a different look and performance characteristics. The most common is Perlin slash Simplex noise. Input output. You provide the noise function with a coordinate and it gives you back a single value, usually between -1 and +1. The output is deterministic. The same input coordinate will always produce the same output value. This is what I was talking about earlier. Okay, functionality and data usage. Okay, cool, cool. How to use it in Nano. Um, you use noise RS inside your update or view loops to influence how to draw things. Okay, so um, generating terrain slash textures. Loop through a grid of points. Use each point's coordinate as input to the noise function. Map the resulting noise value to a color or the z height of a vertex. Okay. Oh yeah. Okay. So yeah. I just remembered. If like for example, if we are generating, so I was talking about how like it generates values across a surface, right? You can use it to, let's say, if you're looping through a grid, for each of those positions, you could pass in that exact position to the noise function, and then you could set the color for that specific like pixel or that grid cell or whatever based on what's returned by the noise function. I should look into if there's a way to do like batch processing. Also, I need to look into if these calculations are being done on the CPU or on the GPU. Like, to what extent are we able to offload these calculations to the GPU if necessary? Okay, organic movement. To create animation, use a 3D noise function, pass the object's position for X and Y, and the elapsed time for Z. This will give you a smooth wandering motion. Speaking of motion and animation, I do need to look into select few animation libraries. There's one library that's meant for a very specific purpose. I forgot what it's called. I think it's called Ease In or something like that. Hold on. Right. So, uh, I need to look into that as well. Actually, this has me curious. Give me a second. Rust animation library. I forgot what the exact name was. Was it called Anim? It definitely wasn't called Tween. It was a tweening library though, or something that, well, I don't know if I would call that a tweening library. Rust animation library, Mina, a simple expressive framework independent animation library for Rust. Animate the properties of any standard struct. You know what? I think this is similar to what I'm looking for. It's not the exact thing that I was looking for. I can't remember the name of the exact library that I was looking for. Let's look up. Let's look up. I was about to say Lust. Let's look up Rust tweening library. There is a library called Tween. So let me open that up and see. Okay. Um, Mina, where is this hosted? Just a second. Oh, okay. This has its own way. So Mina has its own way of its own sort of syntax for animating stuff. I think it's more meant to be used for like um I don't know, a web page UI kind of thing. But okay, wait. Tween is a STD optional tweening library designed for use in games and animations. Is this the one that I was looking for? A tweening library for Rust. Because the thing that I was looking for, it had a specific set of functions, and like it mainly just did that. It wasn't meant for anything else, and that's actually great because wait, hold on. Oh yeah, this is the library. It's called Tween. The library is called Tween. Tween is an STD optional tweening library designed for use in games and animations. It gives you a couple of like functions out of the box, and I think it allows you to build a sort of curve as well if you want. Um, I think the best way to show it would be, hold on, are we still on BRB? No, we're not. Okay. Yeah, I think the best way to show it would be to go to the website. It's called what? Easings.net. Uh, give this a second. Okay, here it is. So this is essentially what the library is built for. Um, so it says here, easing functions specify the rate of change of a parameter over time. They basically do this by mathematically describing what these curves would look like, which I find really interesting. Like we a lot of times, like when people are not used to implementing these algorithms, which you shouldn't have to implement the algorithm, that's the whole point of using ready-made tools and stuff. But like a lot of times when we are used to doing stuff on a very higher level, we forget that these things are being implemented by some underlying code, and so the concept could actually be used even without those higher level features, if that makes sense. Like this curve, in order to visualize it, yeah, we can look at it in this way, but even without a visualization, the algorithm still exists. And so we can still feed something into that algorithm, or apply that algorithm or apply that function across a certain period of time. I don't know if that makes sense, but like, or I don't know if I'm explaining very well what I'm trying to explain. Anyways, objects in real life don't just start and stop instantly and almost never move at a constant speed. When we open a drawer, we first move it quickly and slow down as it comes out. Drop something on the floor, it will first accelerate downwards and then bounce back up after hitting the floor. So here they've demonstrated this. If you look at the thing on the right side, it shows the motion over time. Look at that. And this is interesting. Hold on, they mentioned this over here. They said that this library gives you access to all the tweens initially made by Robert Penner. Oh, you know what? Okay. The library is okay. Okay. I don't think this website itself is using the library. The library is built to, um, the library is implementing these things. I got that part wrong because like for some reason I was thinking that in the back end these all of these things have been implemented using this library, but it turns out that the library is basically implementing these algorithm words, these algorithms. Holy shit! Why was that so hard to say? It gives you access to these algorithms that were made by this person. Um, hold on, there's more. There's a bunch over here as well. Like you can find different types of motions. You see that? There's this as well. Keep looking at the right side of the thing. This is really interesting, like seeing these different types of motions that are being created. Now, the next interesting thing would be being able to define this kind of a curve, um, and then have so basically being able to build the tween ourselves, the tween curve or the tween whatever, being able to build it ourselves without having to um, describe it mathematically, but like internally, whatever we are building, it has to be played out by some kind of algorithm. I need to look into how we can go about setting up a custom. I'm 100% sure there's a way to do that. Um, I just need to look into what the right way is to go about doing it. Okay, so now we can close this and go back to Nano. There was something I was reading, isn't there? Um, that was here, I believe. Yes, okay. So, organic movement. Wow, I went off on a tangent from that to like animation. But yeah, animation is definitely something I need to explore more as well. And I'm going to do that through Nano, of course. Okay, Lyon, the geometry generator. Lyon is a vector graphics tessellation library. Its job is to turn high-level descriptions of shapes like paths, lines, and curves into low-level triangles that a GPU can actually draw. Okay, vector graphics. Okay, core concepts: vector graphics, tessellation, paths, fill versus stroke. Okay, so I know what vector graphics are. It describes shapes using mathematical definitions, a point, a line. But actually, I didn't know this part. What I knew about vector graphics is that essentially that entire thing can very easily, because it's like I actually never thought about how it's being implemented, but now it makes sense, right? Because it's being implemented by mathematical or a set of mathematical algorithms. That's why you're able to zoom into it so much. But yeah, um, describes shapes using mathematical definitions, a point, a line between two points, a curve, a polygon, etc. This is different from raster graphics, a grid of pixels. Nano's basic drawing methods are vector based. Then tessellation, the process of converting a complex vector shape into a collection of simple connected triangles, a mesh. GPUs are highly optimized to draw triangles, so everything must be converted to them first. This is what Lyon does. Then paths. The primary input to Lyon. You build a path by issuing commands like move to this point, draw a line to that point, draw a Bezier curve, etc. Then fill versus stroke. Lyon can convert a path in two main ways. Fill tessellation fills the inside of the shape with triangles. Stroke tessellation creates triangles that represent the line along the path with um, with properties like thickness and line caps. Okay, functionality and data usage. You use a path builder to define your shape, then feed it into a tessellator. The tessellator outputs buffers of vertices and indices. Oh, the tessellator creates the essentially the mesh that you're going to be drawing. Okay. Using Lyon is more advanced than draw.ellipse. It's for when you need to draw complex custom shapes that Nano doesn't provide a primitive for, or for when you need to do it very efficiently. Right, so the final thing would then be fed into draw mesh. All right. Okay, then I had also asked about, oh, this is interesting. It's giving useful ways to combine noise RS and Lyon. Right. Um, so then I asked the question, okay, could you go into more detail with Lyon? I feel like I haven't understood the whole path thing very well. Right. Of course, let's really dig into Lyon's path system. It's the heart of the library. The pen analogy. The best way to understand Lyon's path building is to think of it like giving instructions to a pen plotter or a robot arm holding a pen. You don't tell it where to color in pixels, you tell it where to move. The core object is the path. The path is a path is essentially a list of instructions or events. You create this list of instructions using a path builder. Let's walk through the main pen commands you can give it. Okay, the core path command. The core path, what? The core path commands. Imagine your pen is hovering over a piece of paper. Okay, builder.begin, right, builder.line2. Oh, this is how you define it? Okay, wait, that's interesting. All right. Dude, I wonder if there's a way to, how do I say this? Like, I wonder if there's a way to allow the user to draw a path, draw a curve, and then convert that into Lyon instructions. I should look into that. I should definitely look into something like that. Like maybe I could build my own curve builder and then using the mouse, I can like draw a curve and have Lyon output the instructions. Or maybe there's a much more optimized way of doing what I'm trying to do. Okay, let's build a simple shape. Okay, build, okay. So that's our shape, right? This path object contains the sequence of events begin, line, and end. Okay. Then adding curves, the Bezier commands. Straight lines are useful, but curves are what give Lyon. Oh, what is my mouse? Is my mouse freaking out? Give me a second. Okay, right. Where was I? Straight lines are useful, but curves are what give Lyon its power. Bezier curves are a standard way to define curves in vector graphics. They work by using control points that pull the line towards them, like gravity. Okay, all right, okay. So we can have various. So the builder has various ways to define a shape. Example with a curve, a leaf shape. Okay, from path instructions to triangles, tessellation. This is the final crucial step you asked about. The path is just a description. Your GPU has no idea what a Bezier curve is. It only knows one thing, how to draw triangles. This is where Lyon's tessellators come in. Fill tessellation. When you use fill, the fill tessellator takes your list of path events. It runs a complex algorithm to find out which area is inside your path. Then it cleverly fills the entire area with a mesh of tiny connected triangles. Stroke tessellation. When you use stroke, the stroke tessellator does something even more clever. It walks al- along. What was okay? It walks along your path. Oh, that's where I got it from. I was about to say along. What? Okay. It walks along your path and generates a ribbon of triangles that follows the path, giving it thickness. You can control the thickness, how the corners look, and how line ends look. When you use Nano's Lyon, when you use Nano Lyon's path, Nano Lyon, there's a, hold on, I didn't know that. Wait, okay, that's not mentioned here. Maybe that's a separate thing. or maybe it's somewhere within one of these packages. But yeah, good to know that there is something for integrating Lyon with Nano. When you use Nano Lyon's path helper, it's doing this for you behind the scenes. Draw path draw.path.fill creates a fill tessellator, feeds it feeds it your path events, gets the triangles back, and passes them to the GPU. Okay, where was I? Yeah, summary of the Lyon workflow. Oh, we're at the end. Okay, plan. Imagine the shape you want to draw and the pen strokes needed to create it. Build, create so and so, and call the sequence of commands. Dude, what I'm wondering is, okay, Lyon allows you to generate this, but does it also provide some kind of renderer, or are you meant to be using it with a different? Are you meant to be using the library with some kind of? So is the rendering supposed to be? Is it supposed to be agnostic of the rendering backend? Is it just something that's meant to provide that specific functionality, and then you use whatever rendering backend you want in order to, render the results of this thing? Because like that's valid as well, right? Actually, that's a good idea as well. Making it uh, making it agnostic to whatever rendering backend is used. So then they're just focusing on that one specific thing, which is the path builder and the tessellator functionality, something that builds the instructions and the data and stuff that's going to be that can then be fed into a renderer. Okay, build, create a path builder and call the sequence of commands to describe the geometry. Finalize, call build on the builder to get an immutable path object, tessellate and draw. Pass the path to a tessellator. Oh, okay, yeah, so it does provide a tessellator. It does. Okay, that's so that's something to keep in mind. This thing allows you to define a path and then generate geometry based on that path, and then you can then use that geometry, or you can then use that geometry data to render that geometry on any other renderer. So the library basically handles this very specific thing. Though I could be wrong. Maybe Lyon does provide like a very simple renderer of some sort, or maybe it just says that okay, use it with whatever other renderer you want. Which it's kind of interesting because like I only came across Lyon because I started looking um, into Nano. I didn't go looking for Lyon first. I came across Lyon when I was looking for ways to um, generate stuff in Nano. But yeah, okay. Uh, pass the path to a tessellator like Nano's so and so. Wait, I didn't know that drawpath.fill or drawpath.scope by default, like it's a tessellator that can take in a path. I should keep that in mind. So maybe the functionality that's required to support what Lyon is outputting, maybe that's already built into Nano. Right. So which converts the path's instructions into a triangle mesh that your GPU can render to the screen. So I'm guessing we don't use Lyon's tessellator. We use the tessellator in Nano. Or it could be possible that internally maybe Nano is using Lyon's tessellator. I don't know. I'm gonna have to look into like how that whole thing is working, but it's kind of interesting. Um, which converts the path's instructions into a triangle mesh that your GPU can render to the screen. So the quote unquote path thing is about defining a shape by describing how to trace its outline, and Lyon handles the hard work of converting that outline into the solid triangles needed for drawing. Hell yeah, dude. Okay, cool. Awesome. So, give me a second here. Just a minute. Man, I found this one person whose stream is called is titled VTuber Debut Prep Day 3. But their thing is verified accounts only chat. And so, yeah. Um give me a second. I'm just looking for something. What is this person doing? I'm not sure what this person is doing. Oh, I think they're playing some kind of game. Um, my God, dude, I find people and then it's either follower only chat or verified accounts only chat or okay, there's someone else here. Hopefully, okay, all right. Okay, so their stream seems like a pretty chill stream. The person's name is Silent Struggle, and they're doing a study stream. They're working on quantum field theory, which is super interesting because I know like nothing about this. So I don't even know if the person is talking. I don't know if the person is like looking at their stream, looking at their chat, or what. But uh, where's my? Oh, here. Yeah, we're just gonna go there. Right. Oh, uh, forgot the outro. So that's gonna be it for today's stream. Hopefully, I can stream again tomorrow. Hopefully, I actually wasn't even sure if I wanted to stream today. I was wondering if I should stream or if I should record a bunch of videos to post on social media. Because there's a couple of like NeoVim related videos, like tips and tricks and stuff that I wanted to record. Um, or I might actually do a stream where I record those. I'm not sure. because I could easily just cut the stuff from the stream itself and upload that. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.